Hello, in this video I'm going to go over a parametric equation problem which was from 2022, a couple of years back, the final question on the pure maths paper, so they obviously intended it to be a little bit of a discriminator at the top end. It is the kind of thing that used to be on traditional A-level maths papers as relatively standard. But because we don't see this kind of thing very often these days, it's kind of gone into more, I suppose, a kind of extension to, or a kind of discriminator, tough kind of what's meant to be tough. This actual equation, not that it matters. If you eliminate, you're not expected to do this, but if you eliminated t, you actually get a kind of rectangular hyperbola like this, that face. And I'm just drawing that just for interest, and I will probably use that diagram in part B, but it's not necessary. But we do need to picture what's going on, even if we don't know what the curve is for part B of the question. So yeah, it's one of these things where t is like the general variable parameter, but p is used to signify the particular value at a point. So t is like variable and p is a particular value, and there's this kind of subtle difference between the two. Anyway, I'll get on with it. So we're going to, the question is to find the equation of a tangent. Let's say it's a tangent to this parabola here. What the general equation of a tangent is at a point, 1 over p, 2p. Okay, well, let's just differentiate it. We got x is equal to 1 over t, or t minus 1, which gives us dx by dt is equal to minus t minus 2, or minus 1 over t squared. Y equals to 2t, so dy by dt is equal to 2. So dy by dx is equal to dy by dt over dx by dt. Which equals to 2 over minus 1 over t squared, which obviously we've got to flip over the fraction, that comes to minus 2 t squared. Now that means that that's the general kind of case. We're going to use the particular case when t equals to p for this particular coordinate p. We've got dy by dx is equal to minus 2p cubed, or p squared, of course. Now we're just using whatever method we have. We've got a gradient, m equals to minus 2p squared, and we've got a coordinate 1 over p, 2p. So we're just finding the equation, which should then give us this equation here. As I say, I think because it's a bit unusual, it's the kind of thing, as I say, we used to see this kind of thing all the time back in my day. But anyway, it's probably someone of my age who made the question up. So anyway, I'm going to use y minus y1 mx minus x1. I know not everyone uses that to work out the equation of a line when they know a point and the gradient, but that's what I do. So it's normally quicker and more efficient. So anyway, we've got y minus y1, so that's y minus the 2p there, equals to the gradient m, which is there, so that's minus 2p squared, and that's x minus x1, which is the 1 over p. Okay, so if I multiply that out, I get y minus 2p is equal to minus 2p squared x and if I multiply those two out, I get plus 2p, and then we get the required result from there. Okay, so that is that's our part A. Right, now part B is say considerably more involved. Basically, they start talking about a normal there, and they start saying that the tangent to this meets at point A, and the tangent, the normal, meets at point B, and it's saying basically so that these two sides here are in the ratio that they've given. It's 8 marks, so they're going to make us obviously work for that a little bit, so let's get on with it. Right, I think I might minimize that diagram, make a bit more set space for myself, and tidy up a bit. So off video I just decided to tidy that up a bit, that diagram up a little bit that I just scribbled down. I'd say it's not necessary to have to know what the curve looks like, but we kind of need to know a little bit about what we're doing generally to actually, you know, find a way forward. It says the tangent to the curve crosses the x-axis at A. So the tangent to the curve crosses the x-axis at A here. There. Okay, and then it says the normal to the curve, that's my normal here, crosses the axis at B. So I've marked that B on my diagram. And the bit of what they want us to show is that the ratio of the sides of PA, so let's draw, let's just put that, okay, so that length there and that length there, that's PA here, that's PA, and this is PB, that's in the ratio 1 to 2p squared. So that's what we're doing, but how are we going to go about it? Well, what we need to do is find the equation of the normal, use the equation of the normal in much the same way as we find the equation of the tangent here. So get that and we'll get started. Then we can use the fact that to work out these coordinates, we can find the coordinates of A and B and do a bit of geometry and algebra to try and find a way forward. Okay, so right, so let's just do that. The gradient of the normal at that point at P, and remember the coordinates of P are 1 over P, 2P, is basically minus 1 over the reciprocal of this here. So that's M is, or let's call it M dash, is, or M perpendicular maybe, just to make sure it's a normal, is equal to the reciprocal of that, which is 1 over 2p squared. Change a sign and find the reciprocal. Okay, and we've got the coordinate. So I'm going to use y1, so the equation of the normal, just like we find the equation of the tangent here. The equation of the normal is using y minus y1, take the 1 out there, y minus y1 equals mx minus x1. That gives us y minus y1, which is 2p, m, which is 1 over 2p squared, x minus the x coordinate, which is 1 over p. See from that. Now that's the equation of the normal, remember, and we, just to remind ourselves, part A, they asked us to find the equation of the tangent But we don't need to tidy up like we did before, because it's not asked for the equation of the normal in any particular simplified form or anything. What the question is about is it's about finding the ratio of PA to PB there. So we need the coordinates A by considering the equation of the tangent, and the coordinate B by considering the equation of the normal. Let's do B first. We'll do that now. So we can use the equation of the normal to do that, because at the point B, that we've got y equals to 0. So we have minus 2p is equal to 1 over 2p squared x minus 1 over p. Multiplying that out a bit, I get minus 4p cubed is equal to x minus 1 over p. So I have x is equal to 1 over p. It doesn't look very promising, but I think hopefully it will simplify. Minus 4p cubed. So there we have that expression. Now that means I'm going to write that as over a common denominator over p. Okay. Do I need to? Well, it doesn't matter. I can use either form in a moment. So that gives us a coordinate of 1 over p. If I'm thinking about it, I'm thinking the original might be more useful here. Doesn't matter. So we got the coordinate of b is 1 over p minus 4p cubed, 0, because it's meeting on the x-axis. So then we're going to do the same to work out the coordinate of A on the tangent. So at point A, we have y equals to 0 on that equation. So we have y equals 0, so 0 equals to minus 2p squared x plus 4p. So that gives us 2p squared x equals to 4p. So x is equal to 2 over p. So the coordinate for point A is 2 over p and 0. And reminder, the point right at the beginning of the question, I'll rewrite that again. The point P is 1 over p, 2p. So, okay, just a reminder, we want to find the lengths PA and PB using kind of coordinate geometry things. So we can say PA, I'm going to use Pythagoras, the kind of difference in the y coordinate thing. PA squared will be, remember that's to do with this equation here, to do with those two. That's equal to the difference in the x coordinate, which is 2 over p minus 1 over p squared, plus the difference in the y coordinate, which is 0 minus 2p squared. This here, 2 over p minus 1 over p is just 1 over p, so that's 1 over p squared. And this will come to 4p squared. I will write this over a common denominator, so that's 1 plus 4p to the 4 over p squared. Okay, still not looking too promising, but we're not that far off. We've got an expression for PA squared, and obviously PA will be the square root of that. Okay, so then we can do the same thing on B. That's like this, the difference in the x coordinate of those two. So let's get rid of that. So PB squared is equal to 1 over p minus 4p cubed. Take away 1 over p squared plus the difference in the y coordinates, which again, it's the same point P, it's going to the x-axis, so that's 2p squared. That notice here the 1 over p cancels, so we're just left with 4p cubed, or minus 4p cubed, which squares to 16p to the 6. And this is 4p squared. I might choose to factorise that. Well, I will choose to factorise that because actually it's starting to look a bit promising to me. Hopefully it might be to you. 4p squared out of that will give us 4p to the 4 plus 1. And you can see that there may be some cancelling going on when I divide these two. So it wants to, remember, right back to the original question, it wants the ratio. I'm not going to bother with the dot ratio until the final bit. I'm just going to work out the one divided by the other. So let's do that. PA over PB squared, and just to consider the square of them first of all, is 1 plus 4p to the 4 over p squared divided by 4p squared 4p to the 4 plus 1. And this bit here will cancel, and I'm going to be ending up with 1 over 4p to the 4. So that's quite promising because we're nearly there. PA over PB is therefore equal to, I wish I put the fraction the other way around now, but it doesn't really matter, 1 over 2p squared, which is, we've already shown the thing. So that means that PA to PB, we can see the ratios there. So PA to PB, the ratio is 1 to 2p squared as required. As say, that question used to be quite standard. I suspect it might be have challenged the students in this particular exam a few years ago. Hopefully, even if you can't do the question completely, there's loads of things that could go wrong. You can pick up some method marks through just going through the process. Hope you find it useful, and we will leave it there.